Have you ever looked up at the night sky and wondered about the mysterious dance? One of the constellations of stars, performers like Betelgeuse, a red supergiant star perched atop Orion's shoulder, has recently risen to prominence in the astronomical organization. In 2019, this radiant giant shocked scientists who discovered a sudden dimming, hinting at an imminent cosmic spectacle. Take a journey with me as we explore the mysterious setting of Betelgeuse, investigating its distinctive features, unraveling the science behind its impending supernova, and uncovering the recent revelations made available to us by the wonder of technology, the James Webb Space Telescope. In the vast expanse of the cosmos, where stars twinkle like diamonds, one particular star in the night sky, a celestial entity, has captured the attention of astronomers and stargazers. Similar to Betelgeuse, this red giant possesses the potential for a spectacular astronomical event. What was once just a twinkle in the cosmic tapestry turned into a source of bewilderment when, in 2019, Betelgeuse began to wane, causing scientists to question the fate of this celestial giant. Betelgeuse stands out as the second brightest star in the constellation Orion, its distinctive reddish hue and fluctuating behavior make it a fascinating subject for astronomers. Despite the fact that it ranks 10th in terms of Betelgeuse's brightness in the night sky, its name, meaning the armpit of the giant, enhances the mystery of its celestial persona. Situated at an estimated distance of 430 to 724 light-years from Earth, Betelgeuse is not only bright, but also one of the red supergiants closest to our planet. With a surface temperature of 3,600 Kelvin, it dwarfs our Sun, emitting 126,000 times more light and showcasing a size 16 times larger. Peaking high above the eastern horizon, Betelgeuse, the vivid red supergiant star in the constellation Orion, vanishes from our view behind an asteroid, an occurrence that transcends the ordinary. It marks a celestial reunion, a dance of shadows and light. This date is Monday, December 11th. Betelgeuse, a heavenly luminary in the vast expanse of space, will be occulted by an asteroid named 319 Leona, a brief moment of cosmic wonder. Be on the lookout for Betelgeuse's radiant glow, momentarily eclipsed, creating a celestial fire ring. On the other hand, this spectacle is not for all eyes. Only those positioned along a narrow path from Asia to Florida and Mexico via southern Europe will witness this cosmic ballet. As we ponder the rarity of such events, a question arises. How frequently does the cosmos choreograph these ethereal performances? And what possible secrets could this celestial tango unveil? Could it provide a glimpse into the intricate creation of the universe? Or is it merely a fleeting interlude in the cosmic symphony? Betelgeuse momentarily disappears as an asteroid named Leona moves in front of it, creating a rare celestial eclipse. This fleeting spectacle, visible only to those along a narrow route connecting parts of Central Asia to Mexico, offers a unique opportunity for scientists to unravel the secrets of Betelgeuse and its unlikely companion, Leona, the dance of light and shadows, is something to behold. Betelgeuse has earned its cosmic renown for being a star whose brightness changes, keeping astronomers on the edge of their seats. There's a tension running through the scientific community, a whisper that this giant may be on the brink of a spectacular explosion. Yet, as our telescopic lenses delve into the cosmos, Betelgeuse reveals the truth, showing signs of aging. It is not ready to take a bow out of the cosmic stage. As we gaze out into the vastness, we encounter an astonishing fact. Betelgeuse is around 700 times larger and several thousand times brighter than our Sun. NASA paints a vivid picture, describing the star as so colossal that it would extend past the orbit of Jupiter if it were to swap places with our Sun. Despite this cosmic grandeur, Betelgeuse is a cosmic youngster, a mere 10 million years old compared to the Sun's mature 4.6 billion years. The ticking clock above Betelgeuse is not just a metaphor, it's a scientific reality. The rate at which this enormous star devours its cosmic fuel suggests that its days are numbered. It's a celestial paradox, a giant that burns brightly but burns out quickly. Leona's brief encounter with Betelgeuse is a celestial event. offering us a brief glimpse of cosmic activity. As Leona makes its rare cameo, temporarily eclipsing Betelgeuse, astronomers armed with telescopes and cameras await a spectacle lasting 15 seconds that reveals additional information about Betelgeuse and Leona, its oblong companion. This slowly rotating space rock nestled in the main asteroid belt between Mars and Jupiter holds the key to unlocking mysteries about the size of Betelgeuse and the dynamics of charged gas swirling around the aging star. There is real anticipation because astronomers are unsure whether Leona will fully obscure Betelgeuse, plunging it into total darkness, or if a border of fire will surround the star in an enthralling ring of fire. Astronomer Yannicka Massa, founder of the Virtual Telescope Project, adds mystery, stating that the scenario we witness is uncertain, which intensifies the event's intrigue. It's a reminder that, in the vastness of the cosmos, uncertainty reigns. And each cosmic event is a unique chapter in an ever-evolving cosmic saga. The enormous eruption of Betelgeuse is a cosmic enigma that keeps growing. As we await the celestial eclipse, let's rewind to a time of cosmic turmoil, the great dimming of Betelgeuse, a spectacle that defied expectations. Betelgeuse ejected a staggering amount, 400 billion times more massive than routine solar coronal mass ejections. Our Sun, our familiar cosmic neighbor, routinely sheds its outer layers. However, in coronal mass ejections, Betelgeuse's eruption was a cosmic anomaly, colossal burst that left astronomers astounded. The ejected mass, likely weighing several times more than our moon, was propelled into space in a display of cosmic extravagance. The root cause of this unprecedented cosmic fireworks show is still elusive. Scientists hypothesize that a plume of gas from inside the star, helped by Betelgeuse's 400-day pulsation cycle, might be the culprit. Yet, the cosmic investigation is far from over, and the exact mechanism behind this grand spectacle remains shrouded in mystery as Betelgeuse recovers from the great dimming. Some scientists shift their focus toward the star, armed with tools like the Hubble Space Telescope, a technological marvel capable of peering into the ultraviolet realms. A closer look at Betelgeuse's atmospheric layers. The enormous dimming cosmic event witnessed by humanity due to our proximity to Betelgeuse is a reminder of the countless mysteries lurking in the cosmic unknown. Betelgeuse's future is unveiled. As the cosmic dust settles around it, its questions linger about its future. While the certainty looms that Betelgeuse will go supernova, the exact timeline is still unclear. Scientists predict the cosmic spectacle, a violent explosion indicating Betelgeuse's transition into either a neutron star or, more likely, a black hole, still approximately 100,000 years away. Betelgeuse is a member of the cosmic theater, both an actor and an enigma. Its fate, destined to paint the cosmos with a supernova's brilliance, invites us to ponder the mysteries of the universe. The celestial clock ticks, and as we gaze upon Betelgeuse from our backyard observatory, we are witnesses to the cosmic ballet of creation and destruction. Hubble's watchful eye continues to evaluate Betelgeuse's ultraviolet gaze unraveling. The layers of the star's atmosphere, strange behavior, characterized by the great dimming and then coming back to life, underscores the dynamic and ever-changing nature of the cosmos. In this ongoing investigation of Betelgeuse, humanity has no set formula. Each observation sparks new questions and stokes our never-ending curiosity about the dance of the cosmos. In the vast Milky Way, there are only about 200 red supergiant stars, and Betelgeuse reigns supreme. Its immense dimensions and influence extend far beyond our own solar system. If Betelgeuse were to replace our Sun, its reach would extend beyond Jupiter, which signifies the engulfment of Betelgeuse. Earth, Mercury, and Venus, like all stars, undergoes a life cycle marked by the fusion of hydrogen atoms in its core. As this draws to a close in its cosmic journey, it sheds mass, unevenly establishing a nebula around the star. This nebula, a masterpiece of the heavens, spans 250 kilometers and 30 astronomical units, times larger than Betelgeuse itself. The countdown to the catastrophe is real, and a star of Betelgeuse's magnitude loses approximately one solar mass every 10,000 years, setting the stage for its death. As soon as the star runs out of its primary fuel, hydrogen, and changes to carbon and helium, a chain of reactions caused by combustion unfolds. Carbon-infused neon fuses, birthing iron, and the energy that follows release triggers a supernova explosion, a breathtaking display of nature's might capable of outshining 10 billion suns. The riddle of the dimming star takes another twist as Betelgeuse's story reveals a puzzling aspect. Erratic dimming in 2019. Astronomers and watchers of the sky observed a fading beat. Betelgeuse was a persistent phenomenon, defying convention for months. Expectations and questions arose. Was Betelgeuse dying, or was this a prelude to its looming supernova? As researchers turned their most potent telescopes in the direction of Betelgeuse, they were met with evidence of a great dimming. Even though the star's brightness eventually returned to normal, the star, older than 5 billion years, entered the latter stages of its existence, signifying the potential for an event of a supernova. But the precise timing remained obscured by mystery and elusive of Betelgeuse's unique behavior. Bringing the mystery to light, extensive research of Betelgeuse dates back to the 1st century BC, but the cause of its sudden, likewise atypical, dimming remains a mystery. Astronomers postulate that the outer shell expands and contracts in a cycle, causing fluctuations in diameter and the star's average temperature. Its pulsating nature, coupled with limb darkening, contributes to variations in visual emissions, making the job of deciphering Betelgeuse's mysteries even more difficult. The journey of Betelgeuse through the cosmos takes an unexpected turn. Because it was detected hurtling across the interstellar medium at an astonishing speed of 30 kilometers per second. Ejected from its base in the Orion-OB1 association, the place where stars in Orion's belt are born, Betelgeuse leaves a bowshock spanning over a distance of 4 light-years. However, 2 supergiant red stars, especially erratic ones like Betelgeuse, astronomical problems can arise from calculations. The star's real diameter is a moving target because of its pulsing nature, and limb darkening adds a layer of complexity, altering the color and intensity of combined visual emissions moving away from the center of the star. The revelation from the James Webb Space Telescope is profound. The James Webb Space Telescope, an astronomical marvel poised to change the way we think about the cosmos, turned its gaze toward Betelgeuse, bringing forth data that would shock the astronomical community. The advanced capabilities of the telescope allowed scientists to investigate Betelgeuse's mysteries more deeply. High-resolution spectroscopy, images, and multi-wavelength observations provided unprecedented insights into the star's composition, dynamics, and enigmatic dimming episodes. As scientists pored over the data from the James Webb Space Telescope, the telescope's findings illuminated the complexities, revealing subtle alterations in the outer layers of Betelgeuse that suggested the star's imminent transformation. Revelation sparked a wave of excitement and speculation, challenging existing theories and bringing about a new wave of investigation. The possibility of Betelgeuse going supernova brings up a significant question. Would this have any effect on Earth? The cosmic spectacle occurs a long way from Betelgeuse, providing a level of cosmic insulation, but the sheer power of a supernova cannot be ignored. Discussions ensue about potential consequences from astronomical phenomena visible on Earth to the impact on our planet's atmosphere. The timing puzzle of the supernova of Betelgeuse remains an elusive question. Some astronomers argue that the 2019 dimming episodes may signify the star's approaching end, while others propose alternative explanations. The debate surrounding the timeline of Betelgeuse's cataclysmic event invites us to ponder the vastness of the cosmos and stellar unpredictability. Unveiling Betelgeuse's phenomena, the photospheric puzzle, is difficult. As we delve into the complexities of Betelgeuse, we encounter the intricate dance of its circumstellar and photosphere. The photosphere, a common term used to describe a star's visible surface, becomes a stage 4 material emitted by Betelgeuse, which results in a remarkable display of light emission and absorption. But direct observations become more and more comparable to a challenge to the universe. The visible star's size morphs with the wavelength used for the European Southern Observatory's July 2009 measurements, which provided a glimpse into Betelgeuse's Cosmic theater through images that were taken by a large interferometer for a telescope, a colossal gas plume stretching 30 astronomical units from the star unveiled the spectacle of multiple mass ejections from Betelgeuse's atmosphere. At least 6 circumstellar shells encircling Betelgeuse were discovered by astronomers, merely asking inquiries regarding the mysterious mass loss in the final stages of a star's life, Betelgeuse's dynamics. As we investigate its lengthy environment and the complex dynamics of the mechanism, driving material loss from red supergiants remain shrouded in mystery. These massive stars play a crucial role in the cosmic recycling of matter that shapes galaxies. The most recent developments in interferometric techniques offer a glimmer of hope as astronomers strive to unveil the secrets concealed within. Betelgeuse's atmospheric dance. In 2019, Hubble and other telescopes detected an important event, a significant surface mass ejection from Betelgeuse. Unlike a typical coronal mass ejection from the Sun, this event expelled a staggering 400 billion times more mass. The repercussions were swift, and Betelgeuse underwent a rapid dimming of light from October 2019 to mid-February 2020. However, the dimming event took an unexpected turn, leaving astronomers puzzled as the brightness of Betelgeuse kept the dimming drama unraveled. As astronomers began to develop theories, some pointed to large-grain circumstellar dust, while others attributed it to large star spots. In 2022, a study found that dust absorption, instead of massive star spots, was the cause. But in August 2020, a twist appeared. A second dust cloud surfaced, traced to a cold region on the photosphere of Betelgeuse. The Hubble Space Telescope indicated that obscuring dust resulted from a surface mass ejection of millions of kilometers from the star's surface. The ejected material consolidated during the cooling process into the star's waning dust, causing the star's photosphere to fragment and drift into space. Momentarily blocking Earth's view, the visual spectacle of Betelgeuse's dimming raised questions about the star's behavior. Astronomers have proposed a theory that adds another layer to the cosmic story. Beyond this, the star's visible photosphere undergoes rejuvenation, exhibiting increased luminosity over time. This peculiar behavior, the pulsating structure within the star, like a shattered bell disturbed by its natural process, disrupted light on the aging process of red stars such as Betelgeuse, providing insights into the intricate balance between mass loss and the impending explosion as a cosmic anomaly. Betelgeuse's behavior challenges preconceptions, emphasizing that a major event of mass loss does not always indicate an imminent explosion. The lack of discovery of a massive mass ejection from the star's surface adds a bit of mystery to the story, reminding us that the path from a dying star to a supernova remains uncertain. Astronomers continue to follow their observations closely, stoking new discussion and ideas about the final destination of Betelgeuse's transformation into a supernova. As the cosmic clock ticks, we await the next chapter in the unfolding drama of the enigmatic life and inevitable end of Betelgeuse.